area. So let's look at how to calculate the area of a square. So let's say the side of each of the squares has a length of 2 centimeters. So here, the formula for the area of a square is given by side times side. So another side here, as we know this is a square, we know all the sides are of length 2 centimeters. So here, area is given by 2 times 2, which is equal to 4. So the generic formula here is given by, we say the side of the square has length y, so then it's y times y, which is y squared. So for example, if the side was of length 3, then that tells us that the area is equal to y squared, which is equal to 3 squared, because y is 3, and that is 9. Now here, what we recommend is remember the formula up to this stage, side times side. The reason is that this same formula applies to rectangles as well. So say the longer side is 5 and the shorter side is 3, then the area for this one is given by side times the other side that's next to it. So they have to be next to each other like this. There's 3 times 5. So 3 times 5 is 15. So here the area is 15. Now if the unit is centimeter, we write this out as the unit for the area is centimeter squared. Length has centimeter and area has centimeter squared. Let's look at another example. Now let's say we are asked to work out the area of a triangle. So here we have split the rectangle into 2 triangles. So from that we can tell that the area of one of these triangles is going to be a half of the area of the rectangle we had earlier. So this is the formula for the area of a triangle. Side times side divided by 2. So let's say this one is 5 and this one is 4. So then our area would be 5 times 4 divided by 2. 5 times 4 is 20 over 2, which is equal to 10. So again, if the units were in centimeters, then the area would be centimeter squared. If it was in meters, then our area would be in meters squared. So this works for a triangle that has a right angle. But what if the triangle didn't have a right angle? Say something like this. Well then, we will look at the base height going across, and we will look at the height. It was 2. So here the area would be given by area equals a half times base times height. So for this question, it'll be 5 times 2 all over 2, which is equal to 5. So if this was in meters, it would be 5 meters squared. Let's look at another shape. Let's say we have this sort of rectangular shape where we know the length of some of the sides, so not all of them. Let's say this side is length 10, this one is 2, this one is 3, and this one is 5. And we are asked to work out the area of this shape. What we can do is break this down into shapes we know how to calculate the area of. So for example, we can break this into 2 rectangles by drawing a line here, or we can do it so by breaking it down this way. So again, we have 2 rectangles, 1 and 2. Firstly, we will try to calculate the area using our first breakdown. So we have 2 rectangles, A and B. So let's say this is rectangle A. We know the top side is 5 and the right hand side we have 2. And we know that the area for a rectangle is calculated by side times side or base times height. So this one has area equal to 5 times 2, which is 10. And let's say we have this one as B. So now for this one, it's a bit trickier because we don't know the length of the base or the height, so we need to work it out. Now given this whole one is 10, and we know from this that this part here is 2, that means that this bit here must be the difference. So this must be 10 take away 2, which is 8. So the height here is 8. And then we use the same logic to work out this part. So the top length here is 5, and this part here is 3. So the difference between these two, 5 take away 3, is equal to 2. So we know the base here is 2. So now for this one, our area is 8 times 2, which is 16. And then we need to add the 2 together. So that's 6, 0 plus 6 is 6, and 1 plus 1 is 2, 26. So the area for the total, for the whole shape, is 26. If all these lengths were in meters, then our unit here would be meter squared. Now what if we had cut this in the other way? So now if we had cut it this way, then again we have two rectangles, A and B. For A, we will need to work out the base and the height. So the height is easier as it's already given to us. So that's 10. Now the base here is the whole length up here, less what we don't want over here, which is 3. So that's 5 take away 3, which is equal to 2. So we have 2. So area here would be 10 times 2, which is 20. And for rectangle B, the base we know is 3, and the height we know is 2. So that is known. So here the area is equal to 2 times 3, which equals 6. We add these numbers together, that gives us 26, which is the same answer we had previously. So it doesn't matter how you cut them up, the answer will always be the same. Let's look at a different shape. So here we have another rectangular shape, and let's say the vertical lines have length 2, and let's say the horizontal lines have length 3, and we are asked to work out the area of this shape. So we can cut this in a number of ways, but for example we could have cut it like this. So we have 3 shapes, or we can cut it like this, again 3 rectangles, or we can cut it into 5 rectangles. The answer will always be the same. So now what we can notice is that each of the rectangles with a 2 and a 3 next to it are the same. Only this one in the middle is different. So let's call that one in the middle A, and the other ones that are the same, we'll call all of them B. So let's say this is rectangle B. Then we have height of 2 and base of 3. So the area here would be 2 times 3. And let's say for rectangle A. Now, with the rectangle A, the base is the same as the corresponding one over here. So we can take the top or the bottom. So here it would be 3. And for the height, in the same way, it'll be the same as either this one or that one. So it'll be 2. So in this case, it's actually the same. A and B are the same. So here the area is equal to 2 times 3. But we do know that there's 4 B's. So that means we must have 4 lots of the area of B. So we need 4 times this. So this means that this has to be multiplied by 4. So this is equal to now, so this becomes 6 times 4, which is 24. And this is 6. So now the total here, 6 plus 24, is equal to 30. So our area for this total shape is 30. Now let's do the same one again, but this time we'll cut it slightly differently. So now we have 3 rectangles, and we'll label these A, B, and C. And we'll keep the same sizes, so we go 3 and 2, 2 and 3 and 3. Okay, so let's say this one is rectangle A, and this one is rectangle B. So the base here is 3, because we can take that from here, and the height is 2, as we take it from here. So here the area for A is equal to 2 times 3, which is 6. For B, our height is given, so we can just take that as 2. But the base is the sum of everything that makes this straight line. So we have a 3, this 3, and another 3.
So it's 3 plus 3, which is 6, and then plus another 3, which is 9. So here we have 9. Area of B is equal to 2 times 9, which is 18. Now, the area of rectangle C is also the same as what we calculated for A, because the sides are also the same, 2 and 3. So that means we need to add 6 for rectangle A, 18 from rectangle B, and another 6 from rectangle C. So we add these together. So 6 add 6 is 12, 12 add 8 is 20, 0, carry forward the 2, and 1 plus 2 is 30, which is the same as what we had earlier.
Now here we have two of the common known shapes. So here it's a rectangle and a triangle combined together. So to work out the area of this shape, we can break this down in two shapes that we can recognize, the rectangle and the triangle. Now, let's give these some dimensions. So let's say this is 3, this is 4, this is 10, 2. So again, we look to calculate the area of each of those two shapes. So let's call this one A, this one B. So here this is A. The base is 2 and the height is 10. Because it's a rectangle and this number here is going horizontally, we know the bottom number here is also 2. So here the area for this one is 10 times 2, which is 20. And this for triangle B, we have 3, and the height here is 4. So the area of the triangle B is base times height, so 3 times 4, divided by 2. 3 times 4, which is 12, all over 2, which is 6. So the total area is 20 plus the 6, which is 26. Now let's say that we didn't know this size is 10, and instead we are told this here is 6. Then the height of rectangle A would be 4 plus the 6. So it would be 4 add 6, which is 10. So again, it's important to get the side of the shape that you're interested in, which may need to be built up of other sides. Let's look at another example. Trapezium. Now here, there are 3 sides we are interested in when it comes to working out the area: the base, the top horizontal line, and the height. The formula for the area of a trapezium is given by a half A plus B times height. Now let's say A equals 3, B equals 5, and H equals 4. Then we simply plug this into the formula. So we have area equals a half times A, which is 3, plus B, which is 5, times H, which is 4. And we simplify. So we have a half times 3 plus 5 is 8. So we do the brackets first. Times 4. A half times 8 is 4. So times 4. So to clear this, this is coming from this part here, and this is coming from this 4. And 4 times 4 is 16. So the area here is 16. So if this was in meters, it'll be meters squared. If it was centimeter, it'll be centimeter squared. Let's look at another example. A parallelogram. The area of a parallelogram is given by area equals base times height. So it's the same formula as a rectangle. So why is it the same? Well, this is effectively a rectangle that's been stretched. So if we were to take this corner and pull this towards the left, we would end up with the shape moving this way. And then we move the same amount this way as well from this corner because we're pulling it along, and we end up with a rectangle. Now, let's say the height is 5 and the base is 6. Then the area is given by 5 times 6, which is 30. Area of a circle. So here, the formula for the area of a circle is given by area equals pi r squared. Now pi is a number 3.14159264, and it carries on further. For the purposes of the calculation, we always recommend using the pi from your calculator. So there should be a pi button in your scientific calculator. If your calculator is not close to hand, you can use an approximation 3.14. So let's say r is equal to 2. Then the area of this circle is pi times 2 squared, because r is 2. So this becomes 4 pi, as 2 squared is the same as 2 times 2. The power tells us how many times the base number repeats in the multiplication. And then we plug that into the calculator, and this equals 12.6 to 3 significant figures. Now let's say here we have a circle, but this time we're not told the radius, the r, but we're told the diameter, d. So here, let's say the diameter is 8. Then first we need to work out what r is. So the diameter, d, is equal to 2r. Going to the center of the circle and going halfway gives you r. And the r in here is the radius. So that means that we can use this formula to work out r. So we have d is 8 equals 2r. Then we divide both sides by 2, and we get 4 equals r. So then we plug this into the formula for the area. So the area is equal to pi r squared. So pi stays as pi. R we replace now with 4, because we just worked that out, squared. Now 4 squared is 16, because 4 times 4 is 16. That's 16 pi, which is 50.3 rounded to 3 significant figures. Let's have a look at another example. So now here we have 2 semicircles, so they're half a circle. So we calculate the area of these by calculating the whole circle and then halving it. So we use the same formula of a circle, but we're going to halve the answer. So let's say the radius in the first question is 3. So now the area for this one, we're going to say is half times pi r squared, equals to a half times pi times r, which we know is 3, so it's 3 squared, which is equal to 3 squared is 9, so 9 over 2 pi, and 9 over 2 pi is 14.13 SF. And we use the same approach for the second one, but this time we know what d is, so let's call d equal to 6. So now first we need to work out what r is. So r is a half d. Now this is the same as saying d equals 2r. So that means r is equal to half times 6, which is 3. So now, in terms of calculating the area, it's the same as what we did previously for this question. So area equals a half times pi times r, which is 3 squared, which is what we calculated above as being 14.1 to 3 SF.
You can download the application on Google Play or App Store, and you can visit our website mathslegends.co.uk.